I had 2 days to let the user set up my emulator's controls before pencils down on Hedgehog Day. We care about 3 kinds of input from each joystick. Axes, such as the thumbsticks and triggers, are analog. The program can tell how far the input is from neutral. Directional pads or D-pads are digital, meaning all the way on or off. They register up, down, left, right, and diagonal. These used to be called hats for reasons I won't get into today. Buttons are also digital, and there are usually more of them. The NES has 2 controllers, each with 8 inputs. 4 buttons, A, B, select, and start. 1 D-pad, up, down, left, and right. I added names for these uses of 2 and 8 instead of magic numbers and made other changes to make it compile. That helped me separate the key bindings from the menu state. Then back to what I was working on at the end of yesterday, keeping the game from seeing the button press that closes the menu. Whatever the player was holding would need to be pressed again. Closing the menu didn't make the game see a press, at least for the length of 1 auto-repeat delay. I took notes on the joystick part of the SDL2 manual last night. I learned I had to initialize the joystick on top of other events. I started by counting the joysticks. The sanitizer told me I had a memory leak. I was allocating something and not freeing it at all paths. Here I was leaking the font if the ROM fails to load. Fixed. Back to joysticks. In SDL2, the ID numbers of joysticks are different before and after the program opens them for reading. I looked up how SDL reflects the 4 directions of a D-pad. I made an input context struct. This would hold the button bindings in up to 16 open joysticks. After a bit of refactoring, it still took my input. I wrote a function to read everything from a joystick. This included up to 16 buttons and up to 8 axes. Each axis is 2 bits, 1 for negative and 1 for positive. I treated each D-pad as 2 axes or 4 bits once I looked up how SDL represents directions. Fortunately, it was bitwise and I only had to reorder the bits. I opened all joysticks that were plugged in at program start and closed all joysticks at the end of the program. I logged opening the joysticks. Unfortunately, the static 1 convention to mark a pointer argument as not null cannot be used on a pointer to an opaque struct. I continued making the code compile. I read and stored the state of a joystick. I needed to pass other key press events to the menu so that it could use their scan codes to set a button binding. I spent 4 minutes reading the event section of the SDL manual. And it was a double header. I passed the scan code to the button editor's update function so that it could assign a key to a button. I documented the overall update function's arguments, leaving room for future mouse use. I logged the received scan code, though it was hard to see in the menu. Maybe a name would help. That was better. After the editor assigned the press scan code to a key, I had it ignore all keys for a quarter second afterward. I wrote a crude implementation of auto-repeat. I hid the cursor during this delay between keys. I added a success message once the last button was set and had it draw the new binding. And the buttons weren't going in. I logged the delay logic. The delay time wasn't supposed to wrap below 0. That appeared to fix it, at least for the keyboard. I added special handling for the escape key to end setup early, and it crashed. Fixed. It looked like I had a working key binding editor. I tried it in 240p Test Suite's serial analyzer for a minute. It was sending player 2's presses to the game while inside the menu. I blocked that for player 2 as well. That was a little better. I still needed to prevent auto-repeat in the key binding editor. I tried Serial Analyzer again and it was improved. On to joysticks for the last 24 minutes. I looped through all the joysticks and read each one. Here I had to decide how to allocate bits of a joystick binding to the various axes, D-pads, and buttons of a joystick. I ended up with 4 bits for the joystick ID and 5 for what part. I had to draw the bindings as well, 0 to 15 for axes or 16 and up for buttons. I tested reading some of these on one of my controllers. I pulled all joysticks in the binding editor to see what single button across all of them was being pressed. It was printing the wrong scan code. I added logging to find why. Once I fixed a typo, that was the right scan code. I had it accept joystick scan codes as valid bindings. And it took them. I got joystick configuration in right under the wire. A lot of things happen on the 2nd of February. It's when people take down their Christmas decorations and priests bless candles as symbols of light of the world. It's when both German farmers and Walmart begin their fiscal year. It's also when animals such as hedgehogs, bears, and groundhogs issue their 6-week climate forecasts for the remainder of winter. I had a bunch of little things to do on this last day, and like a famous hedgehog, I had to go fast. I removed some logging from the key binding editor and showed the controller number. Fixed. I grabbed a controller with more than 10 buttons for this one. I fixed display of button numbers 10 and bigger. Fixed. GTK's file chooser shows a list of recent files by default. Showing private files is fine when I'm all alone, but when I have all of YouTube watching, it could break OPSEC. I had to abbreviate button a few places. I wanted to save the window size and button bindings to an INI file, so I wrote an INI parser. Reading text files in C is chock full of gotchas. I ignored leading whitespace in line comments. I looked for the equal sign that divides a name from a value and removed leading space from the value as well. I stripped trailing space as well, leaving null terminators. I knew I'd need to log this parser. I had the main program call the parser. It correctly printed the error message, no such file. I wrote a file on which to test the parser. It trimmed the values wrong. I added logging to every step of trimming. It was identifying name and value correctly. I recognized the scale and button keys. I converted the scale value to a number and wrote that back to the output context window scale value. And the window was bigger. 3 more things left to do for INI. I didn't want to spend time manually writing out all the button bindings in a text editor, so I wrote them before I could read them. I wrote out an INI file when the menu closed. That file needed more new lines. That was better. Did it also work with joystick buttons? I pulled the emulated player and button numbers out of the key, and the hexadecimal binding out of the value. I checked this binding value against keyboard or joystick ranges. Did it keep my settings? Nope. This had happened before, loading something into a variable and then clobbering it by initializing it again. Did this fix it? No, because I forgot to recompile. That fixed it. Let's try Haunted Halloween 87. This is a portable application. It saves settings in the current folder. That's fine for putting a program on a USB flash drive. A program installed system-wide can't write to its folder. Instead, it should save settings in the user profile or home directory. However, this doesn't affect testing the emulator core as much as having the ability to save settings at all. And we're in another double header on the last day. I logged the output context initial size and made myself ready for the final hour. Code yellow and code brown refer to emptying waste compartments. I have used no generative AI in the production of family-size VM, thank goodness. Some cartridges have 8 kilobytes of extra work RAM. Games with a longer campaign connect this RAM to a backup battery so that they can save progress from one session to the next. An emulator needs to save battery RAM to the disk every so often. Save too often and you risk lagging the game. Not often enough and you lose progress if the computer loses power. I chose every 5 minutes and counted frames since the last save, or immediately when loading another ROM. A bit in the INES header tells whether there's a battery or not. It annoys me that QSort and FWrite have opposite argument orders. I had it also save battery RAM when closing the emulator and load it when loading a new ROM. I needed to build a name for the battery RAM file. There I go again, loading something before initializing the machine. To build the battery RAM file name, I looked for the base name or everything after the last slash. Then I looked for the extension, everything after the last period. The shortest file name is x.sav, 5 characters plus a terminator. I had it chop off the .nes extension and add .sav, paying attention to the buffer length. I felt like getting to the bottom of this unused result thing. Maybe later. First I wanted to test if a game saved and test the error messages when it fails to do so. Full Quiet made a save file full of zeros. I played it up to the first save point. The testing build lets me unlock doors through event flags. This let me save quicker, but it wasn't keeping my save. It was yet another problem of load before init. But by that point we don't have the ROM file name anymore, so I had it make the battery RAM file name after loading the ROM and then keep it until starting the machine. I used the teleport and door unlock cheats this time. I made it inside, saved, and restarted family-size VM. And the file was still there. That was good enough for me. I used the last 8 minutes before release to resize the window without closing it and reopening it. I separated closing the output context and closing the window. I had output context creation check for an existing window and resized it if found. I spot checked the title of this window, though I wouldn't have a chance to add the game title. Resizing worked. Stick a fork in it. It's done. And I didn't even need to use a language model. You've seen every keystroke into every source file. On to packaging a release and making a teaser video. In the next series, I can explain why I called it Family Size VM. Let me know if you still want more. And have a happy Hedgehog Day!